So today on a bench we have twins. We have a pair of Simba SSBs. These are made by Pearce Simpson. They're a 23 channel radio, so they're earlier radios. They're crystal synthesized. The customer sent two of these in. He sent this one in. He'd like to have, he wasn't sure if I could make two radios or if it'd just be easier to make one really nice radio and use the other one as a parts chassis. His first problem was, so we'll call this unit number 1 and number 2. Number 1, the best looking one, got damaged in shipping. Not to me. He bought it and it got damaged on its way to him from whoever he bought it from. Poorly packaged. This control here, they call it the Slido tune. That's the clarifier. And actually the mic gain control both took a hit. So actually got them down here. This is what's left of the Slido tune. Yeah, it pretty much just shattered and got shoved into the radio. And then even the mic gain control, yeah, it's got a flat spot on it. It took a hit. Which not so big a problem. That's just the knob. The big problem there is it broke what's behind that knob, and that is the control here. So actually, this is the one out of this radio. So yeah, because this thing has a few other little problems. So what I'm doing is, this is going to be a parts chassis. Taking good parts out of this one, we're going to be transplanting them into this one to make one really nice unit. And then this unit will actually have some extra features. It's going to cover all 40 channels when we get done with it, like this one originally did. So I've taken the clarifier out of this one. Now, older radios, if you're not familiar, nowadays everybody knows, yeah, clarifier, it's usually just a potentiometer, just like a squelch control or an RF gain or something like that. It's just a variable resistor. Older radios like this did not do that. What they had was a air variable capacitor, so a tuning capacitor that you use for, like, tuning a radio, okay? And those are actually hooked up directly into the crystal mixing synthesizer circuit. So they look like this, okay? And that was the problem. When that knob took a hit, the shaft took a hit, and it shattered, because this is porcelain, and it just broke. So you can see I'm trying to reach back here past the camera. The side of it's all shattered out, actually. Where is the other piece of it? Oh, it's in my hand. Yeah, so here's half of that porcelain. So, it's supposed to be all one piece, and you can see how it's bent, and it's not supposed to be. It's supposed to be nice and flat. So, yeah, I'll be able to and it's what I'm in the process of doing. I'm just taking the air variable cap out of that radio. I'll transplant it over here. Kind of convenient the way they made this, because at first I looked at it as like, I got to take the faceplate off, and then I realized, no, some of these little screws, so this actually mounts to its own little plate, and I can get to the 3 screws from the backside to just change this out. So I'll be changing that over. The other thing is, unit number 1, both of these were actually set up for extra channels. Now, unit number 1 here, the unit we want to fix up, was set up for a VFO. So it has a coax cable here that goes up to the channel selector switch. There's a crystal missing, and they have this coax cable goes to that, and they have that routed out through a jack that most people usually don't use in a base station anyhow, the PA speaker jack. So they just ran the coax through that, and then this would have plugged into presumably probably is like a Siltronics VFO. That's one way to get your channels. The other way to do channels in an old crystal synthesized radio is the way that they did it in this chassis over here. And that is with a switch with a bunch of crystals. Now, nowadays, we would not do it this way, because you'd probably be looking at $1,000 worth of crystals right there nowadays. Since ICM, International Crystal Manufacturing, has gone out of business, they were the only reliable source that I really knew of for custom cut crystals at a reasonable price. You were looking at like $25 or $27.50 a piece. I'd have to pull out an invoice, see the last ones I ordered, plus shipping for a crystal, Well, since they've gone out of business several months ago, most any crystal manufacturer will cut custom crystals. And when I say custom crystals, what I mean is these frequencies, of course, these are not standard frequencies for anything nowadays. So it's not like these are off-the-shelf crystals. So if you need these crystals and you don't already have some old ones, that you could make something like this up, you would have to contact a crystal manufacturer, tell them what frequencies and specifications for the crystal, and they will have to make these but one at a time. That's really expensive. The advantage with ICM was they had a database of pretty much every radio ever made. You could just pick up the phone, say, this is the crystal I'd need. They'd say, how do you want to bill it? Give them your credit card number and your crystal would show up in the mail. Yeah, crystal manufacturers, all the other manufacturers around now, yeah, they're happy to cut you a custom cut crystal, but you're probably looking at like $100+ a piece for each one of these. Yeah, and there's like what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? I'm trying to look through the viewfinder. Let me just look at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 extra crystals. And one of these, this one right here, is actually the original 11 megahertz crystal out of the radio. So all of these crystals have been added, and this is an original. So now the problem with this is this was done in what I would consider a rather ugly fashion. It worked, don't get me wrong. They kept the leads short, which you want to do, but they had this mounted right here in the side of the top cover, okay? And then these wires went right down to the crystal socket for the 11 megahertz crystal that they had removed. The problem is, of course, that's kind of ugly. You got this, this big plate here was on the side with this, let me grab it, the big chicken head knob, so that's what you were looking at on the outside of the radio. Not the most attractive thing. So I've had a conversation with the customer, and what I'm going to do, I've come up with a way of kind of hiding this switch. So I think most people are kind of like me, and the customer, because I asked him if it was okay with him. Honestly, most people never touch their RF gain control. I rarely ever do. The only time I really use RF gain controls on CBs is for bench monitor radios, and I have them turned the whole way down because, of course, I'm trying to listen to a radio that's a foot away from it. So I don't want to overload the front end, so I'll usually have them turned, actually, that radio right there, that one is turned, I have the RF gain control turned completely down and the output power turned completely down because that's a bench radio. I only want maybe 1 watt of output power going into a dummy load. I just need some RF energy to leach out of the coax cable into the receiver of a receiving radio, or if I'm transmitting with this one, I want the RF gain turned way down on that one. So like I say, long and short of it, RF gain control doesn't get used a lot. And this in this chassis, you see this is a big radio, and it's heavy. All these things are so heavy. This is not plastic. This is all metal. Yeah, this is back in the day when we built radios that when you dropped the radio on your foot, yeah, you basically had to go to the hospital and get your foot amputated because you've crushed it. This thing is a boat anchor, man. This is all a gigantic big piece of solid die-cast metal. But there's lots of room in here. So what I'm going to do is I'm going to take the RF gain control out. Again, right now where the coax cables, the way they have it currently set up for channels is they have the coax cable going out the PA jack. Again, most people don't use that. So I'm going to take the current VFO, external VFO mod out. I'm going to take the PA speaker jack out of, well, I'm going to leave it in the radio, but I'm going to unscrew it and just tie it up inside the underside right back there in the radio. I'm going to move the RF gain control to that hole, so there's no extra holes. If this radio at some point in time in the future, somebody wants to put this thing back to 100% stock, everything will be here. And then I'm going to move this crystal switch right here, because it will fit inside in the back here. There's plenty of real estate, I guess you could say. And the advantage is I can shorten these wires up even more, because you really don't want to be using wire. Yeah, it's the longer the wires, you got to remember they're crystals. That's basically a variable capacitor right there. The distance between these wires, yeah, there's inductance, all kinds. So you want to keep these as short as possible. And honestly, they're only going to be like that long when I get done with it. I'll be able to let the wires go straight out and straight down to, because this is the synthesizer board. You see right here's a row of crystal sockets and right here. So yeah, their wires are just going to go straight from here, straight down to the board, right to this, the second crystal socket. So yeah, it works out really well. Like I said, I'll just tie the, actually that's not even connected, is it? Oh shoot, somebody's already unhooked it. It doesn't have any wires on it already. Yeah, I didn't even notice that before. There's not even any PA wires hooked up to that jack. So, never mind. I guess I'll just be removing it. Oh, wait a minute. Did they add? Ah, they did. Okay, yeah, this actually has an extra jack. Well, that's kind of stupid. Why did they do that? Okay, here is this. This isn't supposed to have this little 1/8 inch jack. Oh, wait a minute. No. Okay, I know what they did. The external speaker jack is not the external speaker jack in this radio. What they did was they moved the PA jack over here. This used to be the speaker, the external normal speaker jack. They disconnected the wires from that. Of course, that's a 1/4 inch phone plug. Well, most of your external speakers nowadays don't use 1/4 inch phone jacks. They use the 1/8 inch jacks. So that's what they did. They took the wires off of it and installed a separate 1/8 inch jack here for that. So, okay. So yeah, that's actually the PA there, or the external speaker. This is the PA jack. Yeah, okay. So, I guess I need to get back to it here and get some parts transplanted. Actually, the other thing I need to do is, another thing this radio uses, you can see, actually there's 4 boards. There's a power supply board down here. But it actually uses 3 circuit boards here. It has the main chassis, it has the crystal synthesizer board, and then this does not have any of the transmit amplifier circuitry on it. That's actually all on this board back here. So, and at some point in time, this radio had some liquid of some kind, I guess accidentally spilled down through the top cover. It got onto this board. It's all corroded here on the bottom side. There's a small single contact relay on this. I can see it's oxidized. There's a trimmer actually it's a full-size potentiometer mounted to the board. It's oxidized. The advantage is we have a parts chassis, and there's only just a couple wires that interconnect between these 2 boards. So I'm just going to take the good board out of this radio and swap it into this radio chassis here. Of course, it's going to be getting all the electrolytic capacitors replaced, the normal going through, and a transceiver alignment. I do believe I'm going to have to take the clock out of this. Not that it doesn't work. I don't know if it'll show up in camera. I don't know if I can get this faceplate. You can just see there's like a stain right there. I don't know what. There, you can kind of see that kind of shiny spot right in there. It's almost like somebody either again spilled something, or maybe they were lubing the clock. I don't know, but they got oil around the front there, in between the lens and the black part there. So yeah, I'm going to have to pull the clock out and clean that off. So yep, let me get back to it. I need to get some parts swapped over and do the recap. And when I get done, we'll have one really nice working radio and a rather subdued channel modification. So, and actually this, I've looked at the crystals. What it has is of course, crystal synthesis. You're using, actually, let me just grab a service manual here. I have a mixing chart for this radio. Yeah, actually right there. Actually, you can see who it's provided by. I didn't make this up myself. Radioamateur.eu's where this was printed out from. But the way frequencies are synthesized in this radio, you have a block of 11 megahertz range crystals that go from 11 to 11.25. So, and they're in 50 kilohertz steps. And you can see, so in channel 1, or channel 1, 2, 3, and 4, the 11 megahertz crystals used. In 5, 6, 7, 8, it uses the next one, and so on. And then depending on what mode you're in, either AM, receive, or transmit, so these 2 crystals, as you can see, are used in all modes, or all modes for either transmit or for receive. And then these crystals depend, again, but these are the ones that actually mix together here. So you're going to have an 11 megahertz when you're in channel 1 and the 8.1665 mix. When you switch to channel 2, you'll have, again, the 11 megahertz, but then you switch down to the 8.1765 crystal. So the way this channel mod was done, they pulled the 11 megahertz crystal out of the radio, moved that to this switch, and then the crystals that are on this switch are, what is it, 10.950 and 10.9. So there's 2 crystals on here for below channel 1. So that'll give 8 channels below channel 1. And then the other, 8 crystals are above 11.250. So the first higher crystal on this switch is 11.300. And then it goes up 350, 445, 555, and so on. But there's 8 crystals above, and of course each one of those crystals then will give a bank of 4 additional channels. But like I say, I'll get that stuck in the RF gain there. Have talked to the customer about this. What I'm going to do is just use a regular knob. I'm going to set it up so when the knob is in this, the little black dot on there is in the straight up position. That'll be basically a factory radio. That'll have the factory 11 megahertz crystal, that gray one right there, in circuit. So this dial will, your channel selector will operate normally. And when I get this done and this is turned on, you'll see the numbers are actually on this dial. It's transparent, and there's a light back here that shines through. But so you'd turn this from 1 through up to 20, but channel 21, 2, and 3 will be normal. And then when you switch, one position to the right, that'll be the next 4 channels above. So what you do is put your channel selector on channel 23, and you'd go 1 notch right, that'll be up 4 channels. Go 2 notches, that'll be up the next 5 to 8 channels, and so on and so on. And then if you go down, there'll be 2 positions, let's say to the left will be the 2 banks of 4 channels lower than channel 1. But like I say, by doing it that way, from the outside of the radio, you'd never know that it has this in there, unless you looked at the back of the radio, because of course there's going to be a knob now on the back of the radio for the RF gain. But from the from the front, and the thing is, it gets rid of that ugly knob that's, like I say, they had that chicken head knob with that dial sticking out the side of the cabinet, and yeah, it just gives me shivers when I see stuff like it. I hate people that punch holes in covers of radios, and yeah, just take a really nice looking radio like this and then go butchering it by adding extra holes to it, and so we definitely don't want to be doing that. So I shall return when basically it'll probably be back up and running by the time I get back to the next video clip, unless I run into something that I think deserves its own little section of footage. Okay, so I got the control replaced here, the one out of the donor chassis. Got the RF gain control moved to the back, and installed the rotary switch here that was removed out of the other radio as well. I just temporarily have this little piece of fiberglass insulation board. Just temporarily have that stuck in there. When I'm actually done with this, what I'll do is I'll actually glue that in. Because that's so close to the bottom chassis, I just want to make sure that nothing ever shorts out against that ring. Basically, I guess you'd call it a ring terminal, the wire that wraps the whole way around the common terminal for all the crystals. So I'll glue that in when I'm sure everything's up and running right. I put that control in because this is the amplifier board. I wanted to make sure, just to be sure, that no RF energies, excessive amounts leaching into this wiring harness. I wrapped this in a EMI. Actually, it'd be easier to show it to you than it would be to sit here and describe it. It's a 3M number 24 electrical shielding tape, and it's not actually tape. There's no glue. It's just a mesh tubing. So you can open it up. You can see there. So it's get her opened up there. But yeah, I stuck the wires in there and then wrapped that around for some shielding. And the reason I use this instead of just normal EMI tape, the normal EMI tape, of course, you can't solder to that stuff because it is tape. It's a cloth tape, like you'll see me use when I install the Channel King boards. I wrap the digital PWM-driven display ribbon cables in that EMI tape. The problem is that's just a metal impregnated cloth tape. This stuff is tinned, as you can see there, tinned copper wire braid. So I wrap that around there, and then I shoot it out the side here, and that allows me to actually ground it to the DC ground. So that gives us really good shielding around this high RF energy area. Once I got all that done, plugged the radio in, the clock motor ran, I turned it on, and nothing happened. It was completely dead. No lights, no sound, no receive, no transmit, absolutely nothing. Clock was still running, but that was pretty much it. Pretty quickly discovered that it was the on-off switch that was bad. Now, if you work on one of these radios, and actually a few radios like this, it's not just a Pearce Simpson thing. These clocks, you have to remember the clock is an alarm clock. So there's also a switch on the alarm clock module that if you have the radio volume control on-off turned on here, and you set your alarm clock to auto, at whatever specified time you have your clock set to, the radio will turn on. So you can use your radio as an alarm clock. But they actually run, you need to be careful when you're troubleshooting these. Usually in most base station radios, you only have DC voltage present at this switch. In this radio and other radios, not all of them, but a lot of them that have these clock modules, you will also find 120 volts AC here. So your line voltage is present. It comes in here, comes up through a brown wire, and it's this little small brown wire here, and then it shoots out the other one and goes back and actually goes up to that switch and then off to the transformer, and then gets rectified. There's your main filter cap, the bridge rectifier diodes are here. It gets regulated once down to 13.8 volts, comes out, goes to the DC switch, or the I'll get it right. The DC socket on the back. So if you wanted to run this radio off of an external 12-volt power source, so you had a power outage, you could plug in a DC cord in the back of this thing and run this radio off of a battery. But and then that switch either switches between the external, and it has a built-in switch in it as well, and that either allows it to run off of the DC externally, or when you unplug the cord, runs off the internal board. But it comes out there, goes to this fuse. This is your low voltage DC fuse. Comes through this heavier gauge wire here and runs up to this switch on this terminal, and then out these two wires here to the rest of the radio to turn it on. So first thing I did was you turned it on, checked with a voltmeter. I checked, and I had, now these two heavy red wires here, if you follow them, they go up through right there in the bottom of the chassis. Those are the secondary windings of the transformer, so that's your low voltage AC that comes into the power supply board. And I think in this one it's around like 19 volts AC. I had AC voltage present there. When I turned the switch on, I had 24 volts at the filter cap, because once it goes through the bridge rectifier, there's the filter cap, and it's about with 19 volts, that's around what you're going to have, around 24 volts DC. And had like 13.4 volts out of the power supply board. So everything was good there. Went through the switch, had power at the fuse, had power at the switch here. But when you turn it on, no power out. So and turned it several times on and off. It just would never, supply power out. Now that's actually fairly common with these things. I've seen that several times in this type of switch. So if you look inside here, this post right here, the input, is actually a solid metal post on the inside. You can see it, that's, grab something pointy here, that's that solid metal post right there, okay? And then when you flip the switch, the back side of the volume control here has a little finger on it that engages this right here. And you can see how that flips over. And then the other terminal, there's another solid post, but it has this little swing arm attached to it. Okay, so you have the output terminal is attached to that post there, and like I say, that has that little swing arm, and it just comes over and touches that post. So you got the post sticking up, and the other one just comes in and touches it. But there's no wiping action, and when I first discovered this was the problem, I just shorted across this with a screwdriver, and yeah, radio turned on. Yeah, actually I had the volume turned up, about blew me out of the chair. But it arced, and that's the reason that happens. I can see, just when I did it, when I shorted across here, I could see how much power draw there is in this radio. Because you have to remember, when you first engage that switch, now this one will already be charged, but because that's the AC before, and the power supply circuit before the DC portion of the switch. But you still have to charge all the other electrolytic capacitors in this radio, so they're drawing a lot of current. So the instantaneous turn-on current on this thing, on most any radio, it's going to be fairly high compared to its normal operating current. So, and that's what happens. These just flash over. They get a little tiniest bit of carbon on there, and because you've got a round post, okay, and something comes in and touches it, well, you can see there's only a very small, when you take anything round, black here, very small amount of contact area there. So all you need to do is open the turn the switch off, just use a screwdriver, just go in there and, it's not even pitted. I can feel it. It's very smooth there, but I can see there's just a little bit of black residue in there, and just clean that off. Maybe give it a shot of deoxit, blow it out. Actually, what I'd suggest using on these is actually using the deoxit shield, not just the cleaner, but give it a shot of the shield if you have that as well, because the shield is a lubricant, and you have to remember this is mechanical, and it's another thing that can cause problems here is if these little swing arms, you've got one here and one up here, if they start to bind up, when it flips over, you see that makes a nice loud click. Well, that's because I've cleaned it and sprayed some deoxit shield in there. Before, when I would do that, it would just kind of slowly push over. It wasn't a nice snap. It didn't snap into place. So I think that was another part of the problem, was it was just the grease. They put a little bit of grease on there, and it just over the decades has slowly started to dry out. So, a shot of lubricant in there and cleaning the contacts, this thing should be good to go for several years to come. So, like I said, I wasn't sure if I was going to run into any other thing that would need troubleshooting this radio. So there's something, I figure I'd show that. So now I can get this. And these are easy to get apart. If you ever run into this problem, the switches just sit in here, and you've got these 4 little fingers that are folded around at the corners here. Just come in with your screwdriver, pry up underneath of them, fold them up out of the way. They easily come apart. And then put it back together, just slide it back in, push the 4 little fingers over. I usually take a pair of pliers and make sure they're crimped down tight to put it back together. So, if I don't run into anything else, it should hopefully be up and running and done the next time you see it. If not, if I run into something else that needs troubleshot, I'll shoot another section of video on that as well. So, I shall return at some point. Okay, so she's on the home stretch. it's pretty much all done. The electrolytic capacitors have been replaced. I had installed the RF gain control. Actually, that's out of camera view. That's right there now. It'll have a knob when I get her back together. Put the crystal selector switch in the RF gain spot. Changed out the air variable cap. Like I say, I've done the cap change. Have done the alignment. I did run into one problem with the alignment, which I was kind of expecting. If you ever do a crystal modification on a early radio like this, so a crystal synthesized radio, and you're doing what they call a switch mod, which is what's in this now, which is just a rotary switch with a bunch of crystals tacked on the back of it. Now that switch then connects. So what you do is you remove a crystal. That crystal, I think I explained that before. You take that crystal off, that one goes on the switch with all of the other crystals. But then that switch then is attached, to where that crystal originally was on this board here. But it's done with wires. Now, wires, anything metal. If you put 2 pieces of metal side by side, that's a capacitor. If I take these tweezers and hold this screwdriver end here, side by side, that is a capacitor. Right there, there's a capacitor. It's an air dielectric capacitor. If I stuck a sheet of paper in there or something else, or a piece of ceramic, or, whatever. But that's all it takes to make a capacitor. Just bring 2 pieces of metal close to each other. So, of course, you have those 2 wires coming off of that come up to this crystal socket. Well, since those wires act as a capacitor, they're going to add capacitance into that circuit, which is going to skew your frequency in one direction. So when I did the alignment, actually the first adjustment on the synthesizer board is the 11 megahertz crystal. Went to adjust it, I could only get like 10, I could get within like 500 hertz of it. it was 500 hertz low, and I just could not bring the frequency up any higher. I'd turn the trimmer capacitor, and yeah, I'd get to within about 500 hertz, and then it would start to drop off again. So yeah, it just ran out of range. Very easy to do on this one. Each one of these crystals has its own trimmer capacitor, and then each trimmer capacitor in parallel with it. If you look here, you see these little green guys. They're little small ceramic capacitors. So each one of the trimmer capacitors has a 20 picofarad ceramic capacitor in parallel with it. Now, capacitance, of course, adds in parallel, unlike resistance. So I just removed, there actually used to be a capacitor right in here. So I just removed that 20 picofarad capacitor, removing, because I think these trimmer capacitors, I think they're around 20 picofarad, you know, probably like, why guess? The manual's right here. I can just look at the schematic and we'll see. Where is the channel selector? There it is. Yeah, they're 20 picofarads as well. So yeah, they have a 20 picofarad trimmer capacitor and then a 20 picofarad ceramic capacitor in parallel across them. So that's all I had to do. So actually it would have been this one. I removed C14. So it took that total parallel capacitance, you know, in circuit. This would have been, because it's 20 picofarad maximum capacitance on the trimmer, so it's probably going to start at like 2 or 3 picofarad, you know, of tuning range. So, but I took it from a maximum of up to 40 picofarad. By removing that capacitor, that's what I turned that into, was just basically probably around 2 to 3 picofarad at the bottom end to 20 picofarad. Came right into calibration. Now, that's calibrated with that knob now in the 11 megahertz crystal position. Now, when you go to any of those other crystal positions, they're going to be off frequency. That's because there's no trimmer. Actually, one of them did have a trimmer capacitor tacked on there. I'm not sure if you had seen that or not. But because they don't have a, just like this on this board here, where they have a trimmer capacitor for every single crystal, the ones on that switch don't have that. Now, the advantage is this is an older 23-channel radio. There was no such thing as locked and unlocked clarifier back then. You just had a clarifier, which was like what's in this, the air variable capacitor, attached straight down to the oscillator circuit. There was no switching for different between receive and transmit. That law hadn't come into effect yet. So, you know, it's very easy just to, when you switch to one of those other crystals, if you're off frequency, you just turn your clarifier, and that's going to shift your receive and transmit frequency one direction or the other. So, as you can probably tell by the pile of light bulbs on the bench here, I have been rebulbing. And that can be a laborious process, depending how many bulbs need to be replaced. And I started on this one. Both of the bulbs were out on the clock. The meter lights were kind of dim. Actually, most of the lights were kind of dim. You know, if they weren't burned out, they were dim. There was actually, I think, the AM light. That one was nice and bright, but the AM and lower, or the upper and lower sideband lights, yeah, they were kind of dim, and it just is like, man, very uneven. Well, I know why. Of course, this radio's been used. Now, these were the ones, yeah, these two here were originally the meter lights, and yeah, you can see they're kind of burned up. And actually, if you remember, and you'll see it after I get this flipped back up and powered up when I'm completely done with it. Remember that shiny spot on the face, you know, in between the lens and the black of the kind of that surrounds the clock? There's nothing I can do about that. That's actually damage caused by this nuclear hot light bulb right here. And I really don't like the way they did them in these. The way the Sam's manual, because this radio actually came in different versions. If you look in that Sam's manual over there, it shows the speaker right here. It's mounted bottom firing, shooting out the bottom cover of the radio. This radio has the speaker in the side of the cabinet. That's why the speaker wires are right here, because they plug into the speaker that's in the top cover. So like I say, this came in a few different versions. The one in the Sam's manual, all the light bulbs are 12, well actually they're 14 volt. They operate off the DC power supply. The clock in this one, the way they had it run in this, there were 2 more wires on the clock motor for this. That's actually, these 2 green wires went to the clock. And the reason they did that was because these light bulbs, they had them running off of 120 volts AC. And they had them going through this big honking ceramic capacitor. Or not capacitor, resistor. There's a voltage drop. And you can see how hot this terminal board has gotten over the years. I mean, yeah, it's pretty cooked. Yeah, just poor planning the way they did that. And that was original, this system. So, yeah, it's one of those things they, I guess, changed over time, and they just changed those over to run it off the normal DC power supply. So that's the way this has been set up now. But, of course, to do the meter lights, so what I say, this is a laborious process. It is. It can be a very time-consuming process, changing light bulbs, because this one has, what, 1, 2, 3, 4, 5, 6, 7, oh, wait a minute, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so there's 9 light bulbs in this radio. 2 for the clock, transmit light, AM upper lower sideband, 2 meter lights, and a channel indicator light bulb. Well, of course, there's 2 solder connections for each of those. You got to put heat shrink tubing if you're splicing wires together. To get to the 2 for the clock, well, you have to take the clock out. So now you have to take the entire clock assembly out to be able to get to the light bulbs that are tucked down in underneath of there. Yeah, it's a lot of work. Before you'll get 9 light bulbs out, and before you know it, an hour and a half or 2 hours has gone by, because it can actually take that long just to change some light bulbs. But they've all been replaced now. They're all brand new. And I've had people ask me, where did you get those light bulbs, man? I can't find leaded lights like this. Now, actually, and that was the other thing somebody had done. I don't know why. Forgot to mention that. I don't know if it'll show up in camera. Let's see here if I can. It's on this side. Probably never focus. Yeah, it will. It tried. There you go. 8 volt. Yeah, they had 8 volt light bulbs hooked up to the 13.8 volts for the power supply. So now, one of them, where in the heck is the wire? Oh, it's right there. They had a resistor in series. Okay, drop-in resistor. That makes sense. I don't know if they were trying to brighten the lights up by using, because some of them are 8 volt lights. Other ones, the factory originals, which would be these, as you can see, those are 12 volt lights. That's what originally came in this radio. They would have looked like that. They didn't have this metal base. But yeah, now these, honestly, these are almost impossible to find nowadays. Leaded 8 volt bulbs. 12 volt bulbs, on the other hand, like is supposed to be in this radio, they're actually very easy to find. Just turn around here and pull out the drawer. I've got bags and bags of these things. There's nothing special about them. They still make them. Probably the easiest place for the average person to get your hands on these things. Now, I get these from an account from a supplier, but you have to be a business to be able to buy from them. So that's no good, of course, for the average Joe. But if you go on eBay, just type in Vanco, V-A-N-C-O. That's the name of the company that makes these things. Or I don't know if they make them, but they sell them. I'll put it that way. But just type in Vanco, V-A-N-C-O, and the part number for these bulbs is CBL, Charlie Baker Lima, -1X, so -1 X-ray. And you'll find these bulbs. There's sellers on there that sell them by the piece, lots of 10, 25. I think there might even be listings for like buying 50 at a time. But yeah, they're like $1 a piece. If you buy from the people that have they sell them like a lot of 10 plus free shipping, they're $1 a piece. That's a reasonable price for these bulbs. Now, 8 volt bulbs, yeah, that's a whole nother story. Some CB radios did use 8 volt bulbs over the years. This is not supposed to have 8 volt bulbs. That's it's in, like I said, in some places. But if you do ever run into needing 8 volt bulbs, I have not been able to find a source of pre-made ones like this. I just don't. I actually have some, but I save those for my own vintage stereo rebuilds. I don't use those in CB radios. But it's very easy to make an 8 volt bulb like this. So all you need to do is get some bipin bulbs. So when people are like, oh, I can't find any 8-volt bulbs. Hoo-ha. A bunch of horse hockey. There they are. That's an 8-volt bulb. And it just has 2 wire leads. And then all you got to do is just solder 2 pieces of, like wire like this on there. Put a little bit of heat shrink tubing, trim them off way down here. Solder the wires on there. And there, you've got yourself some 8-volt bulbs. You can get these from Newark Element 14. These actually came from MCM. And it cost $1 a piece. Newark Element 14, that's who owns MCM. And there's the part number right there, 25-060. But yeah, there's nothing special about them. They're easy to find. Just MCM Electronics carries them. Newark, or you can go to Newark's website or Element 14's website. Like I say, they're all part of the same conglomerate. But, so now I can, I guess, put this all completely back together. Just the last little tidying up. Clean up the faceplate and the rest of the knobs that haven't already been stuck back on. And we'll get this thing fired up, and you'll see what it looks like with the top cover on. Because I guess that'd be the first time you'll see it, probably, with the top and bottom cover on. Like I say, just the last little bit of cleaning up. You can see the back here, the fuse holders. The exterior is still dirty. Lots of dirt on there. I haven't cleaned anything yet, but the interior is clean now. And you can see it's a really nice, shiny radio. This one was well taken care of. So let me get back to it, and next time you see this, it should be turned on and completely back together. Okay, so here she is all back together now and running. It turned out to be a really nice looking radio. Like I say, about the only real, I guess, 2 cosmetic defects. That kind of shiny spot in the clock area right here. And yeah, like I say, there's nothing you really do about that. I can't even get to it if I wanted to try and repaint that entire area without fear of damaging the lens. Because this is gotta remember, this has a die-cast metal faceplate. It is not plastic. And that's actually part of the die-cast metal. And it's, of course, the entire faceplate was chrome-plated. And like I say, it's heated this up, and you can even see the chrome on the inside edge, right where the light, because there's actually a light bulb that sits right there. The chrome is even starting to peel off on the inside there, I guess, just because they had that light bulbs running off 120 volts, and you could see how it cooked the tubing they had over it. It's just been so hot for decades, basically, that I guess it kind of melted the paint. It's, I guess, about the best description I can come up with. But, yeah, that, and there's one scratch in the aluminum disc in the center of the dial right here. Other than that, really good, clean-looking radio. Cover's in really good shape. Just everything else is really nice. The chrome, the bezel's really nice. Really nice-looking radio. Can actually see everything now because I changed all the light bulbs. Now, I know in the camera, I'm looking through the viewfinder, I can't even see the meters. It's just, they're fine. It's just this camera does not like bright lights. It takes very little to blind this camera. But you can actually see the clock now, because like I say, both of those light bulbs were burned out, and you could barely even see the clock before. And the channel indicator is brighter now. That was another one. They had stuck an 8-volt light bulb in there, and yeah, it was kind of dim, and you could barely see the digits. Now you can see what channel you're on really good. Now, the channel modification that's on this, if you remember, RF gain controls on the back, there's a switch right here. So to use that, I have to rewrite this for the customer, make a nice little neat one, but this is just what I went through and wrote down the frequency. So basically, just, put the radio in, so I have my little switch here. I can, switch the radio into transmit, and there you can see the transmit light there. But what you do to get to the extra channels is, the extra channels are going to be on using both that knob and the channel selector. Because what we've done is we have removed the 11 megahertz crystal off of the synthesizer board. It was moved down here. The 11 megahertz crystal is used in the channel 1, 2, 3, and 4 positions. So if we put the channel selector on channel 1 with the dot of the knob straight up, that's normal channels. So channel 1, 2, 3, and 4 are just what they should be. Channel 1, 2, 3, and 4. But if we go to channel 1 and go one notch to the right. So that's what I got here. Turn the knob right. So turn one notch to the right, and then channel 1, 2, 3, and 4 now become 26. Because remember, this has, whoever had the crystals on that did 2 banks of lower channels, and then the rest of them are all higher channels. But when you go to one notch right, channel 1 is now 26865, 7585, 905. And then if you go to position 2, channel 1 would then be 26915, and then channel 2, 925, 35, 55. And then the whole way through. So it has a total of 10 crystals on that board. There's actually 11 crystals, because one of them is the original 11 megahertz crystal, and then there was nothing installed in the number 11 position. So, if you go from pointer straight up, if you go left one notch, matter of fact, you can see the signal level meter drop down to completely nothing, because it's actually hooked up to an antenna. When it goes there, there's no crystal to oscillate. Actually, you can't see the meter. So bright. If I get in close enough, will it focus on it? Not really. It's just too darn bright. And this camera has a hard time with bright lights. Yeah, you can't see it. Yeah, you can see the needle just barely wiggling through there in the picture. But yeah, I think that's a lost hope trying to get it to focus on that. But yeah, so like I say, that gives... So there's all the channels it's possible now. 8 channels down, then what? 4, 8, 16... What, 32 channels, yeah, because it's going to have 1, 2, 3, 4, 5, 6, 7, 8. So yeah, possibility of 32 upper channels. So, yep. And like I say, doing it this way by moving it around, it looks really neat. There's no big clunking hole, drilled in the side cover. From the outside, if you weren't to look at the back and see that there's a knob in the jack, or the hole where the PA jack used to be, you really wouldn't know that there was any modifications done to this. So, all the other controls still work nicely. And this was Pearce Simpson's at the time. This was basically their flagship radio. I think in, what was that, 73, or, no, I guess it had been 74. Towards the end of 74, I think this thing cost like $480, I think. Yeah, I think it was somewhere around $480. The price actually went up. It was originally like $429, I think, in like January of 74, and by December, I think the price had increased to like $280 some dollars. But like I say, this was a well-built radio. Nice big heavy cover, die-cast metal faceplate. We ain't using no plastic here. So, and just in case, let's take my little test fixture and adapter off here. Just in case you hadn't noticed before, this does use 3-pin microphone jack. So kind of, antiquated again. That's something else that kind of gives its age away. It only has 3 pins, but because this is relay switch, they don't need a 4th pin for a receive line. Because usually in most of your modern solid-state radios, just think of a Cobra 29. If you don't have a microphone plugged in, you don't have any sound coming out of your speaker. That's because the receive line is actually providing the ground for the speaker in the radio. So it's actually provided through your microphone cord. Back when we had relay switching, we didn't need that. We only needed 3 pins. Audio, ground, and then the transmit. And usually, not all radios, but the majority of radios, all that did was, if you actually check for voltage at these pins, on a lot of earlier radios, 23 channel radios, and on back, even into the tube type days, you'll actually find voltage on one of those pins, and that's actually an easy way to figure out the pin out of a radio. So if you have an old radio, 23 channel and before, now it could have any number of pins. It could be a phone jack for all that goes. It could be a stereo. Now this is a mono plug, but it could be a stereo jack. Those were very common, especially in the tube type days. So there'd be an extra ring here. But easy way to do a pin out on an early radio like this is turn the radio on, take a voltmeter, and test for voltage at all 3 of those pins. If one of those pins has, now if it's a radio like this, it's probably at the most you're going to see is your power supply voltage, which is 13.8 volts. Now if it's an old tube radio, you can have up to 110 to 120 volts DC there. You know, a lot of your old tube radios, that's what the relays were. The coil, the actual coil of the relay operated at 110, 120 volts. So don't be surprised on the old radios. Yeah, there's high voltage at this mic jack. But like I said, you can check. So if you find one that has voltage, that's going to be your transmit line. Then turn the radio off. Best just unplug it too. And check for ground. So then you can just go to like your speaker, let's say, and this is actually, you know, without having to take the covers off, if you need a ground, another thing you can use is, like, if it has a headphone jack, you can use the headphone jack outside here is going to be at your DC ground potential, and just use an ohm meter and check for one that has basically extremely low resistance. So you're looking for like less than 1 ohm. That's going to be your ground pin. That leaves only 1 pin left. That's going to be your audio into the mic jack, you know, from the microphone cartridge. So, like I say, fairly easy to figure these out without even having to take the cover off of the radio. But there you go. There's a Pearce Simpson Simba SSB. Ready to head back and get used on the, what do they call that? The classic radio, because this customer is in an area where they have a classic radio roundup on, I think it's Wednesdays and Thursdays. So I guess if you're in the Philadelphia area, and you might be hearing this radio at some point in time.